Hi, everyone. A very warm welcome to this webinar on onboarding enterprise applications to Azure Red Hat OpenShift 4. This webinar is brought to you by Biqmind together with Microsoft and Red Hat. I'm Joanne from Biqmind and your host for today. Before we begin, a little bit about Biqmind. We provide services and software to help companies in their cloud-native journeys. Our products include discovery workshops, short focus programs that allow you to deliver practical goals, use cases, and action plans within 1 to 3 days. We also provide specialist services, advisory and implementation services to help bridge gaps around people, process, and technologies. Last but not least, we build software to help enable the use of cloud-native technologies such as Kubernetes. As part of this webinar, we're also providing a free half-day assessment. For teams looking to implement Arrow, this half-day consulting session could be useful to help you establish organizational readiness, as well as prioritize pain points and identify potential pilot projects. You can learn more and sign up at bit.ly/Arrow assessment. Without further ado, let's introduce today's speakers. We have Ashwani from Microsoft. Ashwani is the Azure Cloud Native Solutions Leader for Asia. We have Chuck from Biqmind. Chuck heads up software architecture at Biqmind and is also a CNCF ambassador. And we have Edwin from Red Hat. Edwin is an architect with the Solutions Technology practice. Today, Ashwani will take us through Arrow and the benefits of running OpenShift on Azure's world-class infrastructure. Edwin will look at the value of OpenShift for the enterprise and how Arrow 4.3 accelerates developer productivity. Finally, Chuck will take us through considerations and approaches for onboarding enterprise applications to Arrow 4.3. Without further ado, I'll pass over to Ashwani. Thank you.
Good morning, folks. Thank you for coming and listening to us on the webinar today. I would really love to talk to you about why Microsoft and Red Hat have partnered together on this container Kubernetes offering. I'll give you a bit of history on how we are collaborating, where we started from, and how we are developing and supporting customers together. And my other colleagues will walk you through the detailed solution capabilities as well. So first and foremost that we look at is 95% of the Fortune 500 companies trust their business to run on the Microsoft cloud. Okay, and as you can see, most of these customers are also Red Hat customers. And in fact, 100% of Fortune 500 companies in these industries rely on Red Hat. So sectors like airlines, telecommunications, healthcare, banking primarily. A lot of these customers are OpenShift customers, and a lot of these also use RHEL. So customers came to Microsoft and Red Hat as in, we want to be using both. Can you look at how we can help make lives easier for us? So that's basically was a key indication for us to start working together and collaborating together. So Microsoft and Red Hat have been partnering together for more than 5 years, close to 5 years. We started our journey way back in November 2015. We started simply with supporting RHEL on Azure and treating it with first-class support, and the strength of this partnership has been built on the piece of work. More than 50% of Azure workload runs on Linux. But as you can see, the partnership and the relationship has grown quite a bit now. So other than RHEL on IaaS, which was our first joint effort, then we saw around 2015, the entire container platform starting to get acceptance from the industry. So we decided to look at making OpenShift together. So at Red Hat Summit about 2 years back is where we announced the general availability of Azure Red Hat OpenShift, the first party fully managed Red Hat OpenShift service in the public cloud at that point in time. Now it also helps that at Microsoft, we have a lot of folks who does and contribute to upstream Kubernetes. So anything that we do that helps upstream Kubernetes helps OpenShift as well. And that in general helps both companies. Now we also ventured into a few other areas being SQL Server on RHEL and even Windows containers. So we have SQL operator as well available now. And we have customers in production running SQL on RHEL in production, on-premise, as well as Azure. Also, another key aspect that we're starting to drive and we're seeing a lot of acceptance from the industry is specifically around SAP running on RHEL on Azure, because that's a very close partnership that we have specifically in terms of the hybrid support that RHEL has on Azure. So that's the key aspect of it. Now, from an OpenShift perspective, we have two engineering teams working together every day, having Scrum meetings and conversations on Slack channel. By building this service, we are finding and fixing bugs that will benefit everyone using OpenShift on Azure, not just the service. So what we hear from our customers around the world is that their ability to create value for their end customers, now both internal as well as external, depends upon your ability to deliver applications faster. Now, it's really your ability to be great at application development and app delivery, which will help you differentiate your business, engage your customers, and find new ways to create value, and that could turn into possible revenue opportunities for you. And containers and Kubernetes fundamentally enable DevOps, microservices, and cloud-native application development. And we would like to think that OpenShift on Azure is the best platform for you to deliver applications across the hybrid cloud. So a lot of people have gone into the containers adoption mode. They've realized the complexity that comes in. So they said, okay, let's get and look at adopting an orchestrator like Kubernetes, which will help us manage the containers on their own. But having said that, even though enterprise are ready to adopt it, they're saying Kubernetes is not an easy job. In fact, 75% of the enterprise users will say that's the complexity of Kubernetes, which is a blocker for us to adopt containers. So that's the biggest problem. Now, why is that happening? Because if you look at it, installing and getting Kubernetes up and running is not a few hours of job. It can take up to a couple of hours because it requires a lot of aspect. You need to look at the install aspect of it in terms of how do you set up the OS, how do you look at validating whether it's according to the policies and the guidelines that you have. Then you need to look at, okay, if I need to do this again and again, look at templating it. Then you go across, okay, deployment, where you look at, your identity, security access, your role-based access control, then setting up your ingress, and how do you get all the firewalls in place? How do you look at your build and deployment methodology? Then you look at the harden and operate space as well, which itself is a lot of activities that a team has to do. And if the entire team has to do it day in, day out, it's not a trivial job at all. So Red Hat has done a real great job by making OpenShift, because they've really taken care of the install, deploy, and hardening part. And where Microsoft comes in with Azure Red Hat OpenShift is primarily around the operate part. So let's look at what exactly is what I'm talking about in detail. So containers, as I said, comes with their own challenges. In terms of, okay, how do you look at container security, whether I'm meeting the compliance that my industry is set up, whether my company is set it up, how am I looking at scanning my images, whether the images are secure, am I updating and patching it at the right time. The other aspect, other than getting the applications up and running on containers, is how do I look at data management, because that's the most critical part that comes in. So how do you look at that aspect of it? So, and third but not the least is your application delivery. If I have my application running, how do I have the capabilities out of the box, or do I need to integrate other tools to help me monitor it, manage my applications? How do I monitor? So all those things is something that Red Hat really makes it easy, because it's got a trusted version of Kubernetes that it supports. It basically, what it does is it makes time free. It gives a lot of capabilities which otherwise you would have to do it yourself or get in third-party tools to do it. And that's where it frees up a lot of time for your IT ops team and your developers to really work on the value that they're supposed to provide, that is writing your business applications. So OpenShift on containers platform, basically, is the way I look at it is, if you go and ask customers running Kubernetes and then running OpenShift container platform, not everybody will really like, in terms of saying, okay, it's got a lot of things which are reduced, but I still have to do a lot of tasks. So you've got to look at, in a traditional environment, you need to look at deploying and managing a lot of supporting infrastructure. So you end up managing a lot of things yourself, right from the time you create a cluster, your network configuration, your monitoring and logging, right down to securing, patching, and updating the cluster. Now, all this takes time and effort. So if you look at it, your cluster architecture itself is, you got a lot of nodes, you have a set of master nodes, your infra nodes, and your worker nodes, and that requires a lot of effort. So what we do primarily in Azure Red Hat OpenShift is we take all the complexity away from you and we manage it. So right from the time you get OpenShift up and running on Azure, that is Azure Red Hat OpenShift, we manage your clusters, we take care of the security aspect of it. Okay, so you don't need to worry about setting up your monitoring, your logging, your network configuration, and even from a support perspective is where we are there to support you. Whereby what we ensure is you have time to do what is meant for you, that is your core business, that is your core business logic that you write in the form of applications. So I'll just move to the next slide, trying to summarize what this overall offering is. If I were to summarize it, this is the only offering in the industry which is jointly engineered, operated, and supported by both Microsoft and Red Hat. And it's built for enterprise with security and compliance as the topmost priority. Not everyone wants to manage their own databases, so we enable developers to easily integrate to Azure data services like MySQL, Postgres, and Cosmos DB. So you can go into the portal, Azure portal, create a Mongo or a Cosmos or SQL instance, and kind of have best of both worlds. Although this is a fully managed service, we do understand that you want to scale on demand because that's what customers today want. They want to pay as you go. So that's where we've added the capability as well for you to allow you to scale on your own terms. And that's where basically, if you look at it, if you were to create a cluster on Azure Red Hat OpenShift, you would be able to spin up a cluster in less than 12, 13 minutes. The key aspects that a lot of customers have asked us right from the time that we've gone GA on this service is, how do you look at support? Do I need to work on how many people do I need to approach? So key thing that we say is, because this is a jointly engineered, operated, and supported platform, there is no back and forth on, oh, it's an Azure platform or it's an OpenShift platform. It's our problem together and we solve it together. And best is we have a unified support operations. So the customer sees just one interface to this. So they log a ticket through the Azure customer support portal. But in the back end, we have Microsoft and Red Hat engineers that are sharing the same ticket data in our integrated case management system. A lot of Red Hat engineers now have what we call business guest accounts and SAW, or rather secure access workstation devices. And these SAW devices are secure. These are the exact workstations that our Azure engineers have, and this allows us to jointly support the customer, but still keeping all our certifications from a compliance perspective in place. So we can wake up our Red Hat engineers and Red Hat can wake us up, and it's a very nice way to manage a service like this. This is very important to the kind of customers that both Microsoft and Red Hat have. And that kind of talks and it kind of shows how we integrate support in the backend. So we have stuff like daily Scrum, as I mentioned before, and we don't treat this like a regular partner. It's a best of breed service which is offered jointly by both the partners. So these are a few capabilities that have come into OpenShift 4.3. And my colleagues and my friends from Biqmind and Red Hat will cover these in detail as we go through this webinar. But the key aspect that I really want to talk to you from an Azure and an OpenShift perspective is, if you have an existing contract or an existing enterprise agreement with Azure with Microsoft on Azure, you can use your monetary commitments as part of that contract to use Azure Red Hat OpenShift. So just to summarize this in terms of the core benefits of what you get when you look at deploying Azure Red Hat OpenShift. The first thing is pay as you go. So you don't need to get into a 12-month upfront commitment. If you decide that you want to have X amount of nodes, you spin it up. If you don't require it at the end of the day, you can spin it off. So you go spin up your cluster and spin it down. You can do it on a daily basis, and because it doesn't take more than 10 to 12 minutes to spin up a cluster and tear down a cluster, you can do it, and you pay Microsoft on an hourly basis. Same is the case that it applies to both the master nodes as well as the application nodes. Also, if you look at saying, okay, I have a fixed set of nodes which I know I'm going to run for the next 12 months. You can use you can get up to 40% of discounts by reserving what we call as reserved instances. So you can say that I will need a 3-node cluster for the next 12 months. So you end up getting close to a 40% discount on the overall cost of Arrow across. And that's where basically it makes life easier, because you have you have identified what your workload is going to be for the next month. So I have customers which will have a combination of reserved instances and a pay as you go depending upon your needs. Okay, also we have a wide variety of VMs which are available to meet your different business needs. So if you're looking at normal applications, or you're looking at machine learning or deep learning, so we have different kinds of CPUs which are available for you. I spoke about the integrated support and operations that both Microsoft and Red Hat offer. So, and we have an SLA, guaranteed SLA of 99.9%. So coming to my last slide before I hand it over to my colleague, is from an availability perspective, Azure Red Hat OpenShift has 2 versions that we are supporting. So the latest version is 4.3, and that is available in 4 regions across Asia, so which is primarily Japan East, Japan West, Singapore, that is Southeast Asia, and Australia East. There are 4 other regions where Arrow 3.11 is already available, but Arrow 4.3 is going to be there by end of this month or early next month. Okay, so feel free to go to the Azure, so to go to portal.azure.com and try it out as part of your evaluation exercise. With this, I would like to hand it over to my colleague from Red Hat, Edwin, to walk you through the capabilities of Azure Red Hat OpenShift and what it offers specifically also from a developer perspective. Over to you, Edwin.
Hello, everyone. This is Edwin from Red Hat APAC Solution Technology Practice Team. Let me tell you 2 things about in this session. The first is the value of OpenShift in terms of how OpenShift had to operate container in the enterprise, and how OpenShift had to adopt container for the enterprise application development. And the second is Arrow 4.3 is running based on OpenShift 4.3. So I would like to share new features which is helping to empower development productivity. In terms of OpenShift development console, tools, microservices development, frameworks, and built-in CI/CD tools. Let's talk about Kubernetes implementation in the right way for the enterprise. While it actually is not that hard to download and install Kubernetes, getting it really ready for production to run business critical applications for an enterprise takes a lot more effort. There are a number of things that need to be pieced together, tested and hardening for operations in terms of security, networking, and storage and enterprise app operation. For instance, just take identity management with Kubernetes. You will be providing access to critical internal systems to employees, partners, and customers. You need to adhere to the security rules established in the company. The way to do that is to write an integration between Kubernetes and your company's approved LDAP. That requires knowledge of DAX, the open source identity system, Kubernetes and integration system to LDAP. Similarly, you will need to hook up Prometheus, open source monitoring and alert system, or hook up another monitoring system so you can get full visibility into your Kubernetes operations in testing and production. This is why we are saying Kubernetes don't like this hard. So we grouped 3 categories, issues and challenges that companies face when they adopt container platform like Kubernetes. We hear about that. The first is container security and compliance. And the second is data management, like install, upgrade, and etc. And third is app development and management. Let me go through what is the value of that OpenShift provides in each of these categories. We take container security very seriously and take a holistic approach to deliver what we call the trusted enterprise Kubernetes platform. Containers are Linux, and so is Kubernetes, because we also provide LEL, which is trusted by 1,000s of enterprise worldwide. We can deliver a secure platform across the stack and stand behind it with long-term support. We recognize that keeping up with the frequent upstream release can be challenging, and we are investing in automated capability like the operator framework and over-the-air updates to make it easier to keep up to date with the latest innovation coming out of the community. While customers have a demand on learn application in many clouds, they also want to reduce the amount of operational complexity that comes from multi-cloud strategy. OpenShift enables customers to have a consistent development and operational experience across any combination of cloud, public or private or bare metal. It's all about the development. It's all about the developers, and we are investing in automation capability in OpenShift, CI/CD pipeline, A/B testing, and etc. Developer tools like Code-Red Workspace and Cloud Native Framework include Spring, Serverless, and Windows Container to inspire developers to create the best code. No matter what application you are building, chances are you can improve developer productivity with OpenShift. So we call the OpenShift Container Platform is a smarter Kubernetes platform. Kubernetes itself is not the end game. Our objective of adopting container is that deliver application with modern development practice like DevOps and microservices architecture to deliver business value to the market more faster and flexible way. To enable this OpenShift with this foundation of trust enterprise Kubernetes platform, we add productive enhancement to deliver an application platform with all the components you need that are fully integrated to build, deploy, and management containerized applications. Kubernetes updates, security patches, and component updates can be deployed with a single click. Based on Core OS, OpenShift can actually update the underlying operating system and scale at node level, which is particularly useful when you deploy OpenShift on cloud infrastructure because the entire cluster can scale up and down based on your application needs. As mentioned before, lots of new features comes with ARO 4.3, which are a part of OpenShift 4.3. From the Arrow 4.3, OpenShift is running with Kubernetes 1.16 on the Core OS, Red Hat Enterprise Linux Core OS. Core OS is an immutable container-optimized Linux OS host that is delivered and installed as a component of the OpenShift. And also, Arrow 4.3 includes service mesh and serverless for modernized application development, like MSA and event-driven function-based application. There are also a couple of tools for developer in Arrow 4.3, audio and other development tools. Let's go through features one by one in the next slides. I will talk about new features which are related to develop and operate application on the OpenShift platform, and how OpenShift have to accelerate developer productivity. Let's talk about OpenShift 4 enables a cloud experience everywhere by automating data management. OpenShift can learn from bare metal to public cloud and operate it as the managed service like ARO. But OpenShift provides the necessary tooling and process automation to enable teams to operation Kubernetes efficiently, and also provides consistent environment to the developers. OpenShift cluster operators from OpenShift 4 is making available cluster automation and manage the lifecycle of the cluster component throughout the platform. And cluster operator makes upgrading OpenShift clusters in production a risk-free and repeatable task, and as simple as updating an application on your iPhone. Let me tell you about Operator Framework. The Operator Framework is a set of tools that helps you build and learn operators on a Kubernetes cluster, including an SDK to get you up and running quickly. Not only used on building cluster automation, this operator component is also using to manage application's whole life cycle automation. Install and deploy app to the cluster and monitoring and managing through the operator framework. So you can simply say operate codify of operational knowledge and workflow to automate lifecycle management of containerized applications with Kubernetes. So how do you get these operators in the OpenShift? The Operator Hub was launched by Red Hat and other partners, Microsoft and AWS and Google. It provides a single place on the internet for developers to publish operators and for customers to find and consume created operators. These operators meet certain quality standards, so you can have the confidence they deliver what they promise. You can deploy these operators on any Kubernetes distribution, not just the OpenShift. But we've also integrated the Operator Hub into OpenShift, where you can also find fully certified operators from our partners and us. That meets a very high bars of quality standards, like Elasticsearch logging, EFK. Inside of OpenShift, admin have full control over which operators are installed across the cluster and gain tools for upgrading them from a center point. Engineers interact with operators in a self-service manner, just like any other Kubernetes object. Here you can see a developer's view of all operator capabilities exposed to them, which self-service access to manage them. Let me talk about OpenShift 4.3 features and ARO 4.3 features for developers. ARO 4.3 provides familiar Red Hat OpenShift experience. You can use the tools and command you can already know and use in the OpenShift cluster. OpenShift enables developer productivity. No matter what architecture you choose for your applications, what program language the developers find most useful, and what services you want to use as building block, OpenShift provides a single and consistent development model across the build, test, deploy, monitor, and review lifecycle of the application. First is a self-service infrastructure. Developer can provision what they need on demand and skip waiting for hours, days, and something weeks for infrastructure resource. They can they are provisioning from the OpenShift self-service provisioning service. Second is consistent environment. OpenShift makes sure the environment provisioned for developers and across the lifecycle of the application is consistent from the operating system to libraries, runtime versions, and even the application runtime in use in order to remove the risk originated from inconsistent environments. And automated build and deployment. OpenShift gives a choice to developer to build their containerized application themselves or to have the platform build containers from the application source code or binary. The platform then automated deployment of these applications across the infrastructure based on the characteristic that the teams has defined for the app, such as how much resources should get allocated and where on the infrastructure they should get deployed to be compliant with third-party license. Continuous delivery pipeline. OpenShift provides out-of-the-box support for the CI/CD pipeline. so that development team can automate every step of the application delivery process and make sure it's executed on every changes that is made to the code or configuration of the application. And configuration management and sensitive data management is built in the platform to ensure consistent environment agnostic application configuration is provided to the application, no matter what technology is used to build the application and which environment it is deployed. And also, application and logs and metrics is provided and integrated OpenShift monitoring and log management system, which is Prometheus in the OpenShift 4.3 and Elastic search-based EFK stack to aggregate the logging of the application. And also OpenShift provides streamlined developer console. A developer-centric perspective offers a simplified view of Kubernetes concepts, so developers can focus on what really matters. The console allows developers to import their source code from Git or GitHub, view and manage app configuration and workload details, and deploy their applications all through this dedicated interface. Improved topology view in the ARO 4.3, we added a lot of contextual actions plus allow you to quickly toggle to the list view to give access to developers all relevant info for their apps. We have made it simple to group and bind apps and services together from the topology view. This is really about making the developers as productive as possible without having to get into Kubernetes underbelly. The next one is enable development to enable developer productivity. We provide a couple of development tools for the developer. In terms of developer tools, Code-Ready Workspaces provides an Eclipse chair-based developer IDE that is tightly integrated with OpenShift. Code-Ready Workspace provides support for development team to build application together. But even if you are using Visual Studio Code, IntelliJ, or other IDE, OpenShift plugins allow you to use your existing tools, deploy your apps on OpenShift. And for command line users, ODO gives you a very powerful CLI to deploy applications on the command line. Code-Ready Workspace. There are some key advantages to use Code-Ready Workspace with OpenShift in terms of accelerate onboarding, pre-configured and shareable dev workspace with all tools pre-installed workspace, including DevOps integrations, can provide to the developer. In terms of consistent workspaces, identical workspace to remove works on my machine and enhance team collaboration. In terms of protect source code, no code on the hard to secure developer and personal laptops. If you secure your source code repository with like GitHub secure functions, you can mitigate source code security risk. OpenShift ODO is a fast, iterative, and straightforward CI tool for developers who write, build, and deploy applications on the OpenShift. OpenShift supports a very broad range of application types of framework. Service mesh and serverless are exciting technologies that makes it easier to build and learn microservice architectures, and we support both in OpenShift 4 and ARO 4.3. The service mesh is a layer that manages the communication between the individual services that works together as an application. The routing rules and communication security can be managed by service mesh instead of being hard-coded into the application or manually defined. The OpenShift service mesh is based on Istio, but is also packaged with Jaeger and Kiali to improve observability of the service mesh. This picture demonstrates traffic management of the service mesh for the A/B testing. Like this, you can easily control traffic at the application level to leverage service mesh traffic management. And Jaeger, which is packed with OpenShift service mesh, can visualize the service execution times across the application. This helps identifying potential latency issues in each services. Kiali works to visualize the service mesh topology, identify which services are part of the service mesh and how they are connected. And Kiali also enabled to understand the topology and health of the service mesh. The next is OpenShift serverless. We have a backed serverless capability into the platform with OpenShift serverless, enabling almost any containerized application to run serverless. That means you can choose any program language of choice and enable auto-scaling behavior, scaling up to meet demands and down even to 0. Beyond auto-scaling of the scaling for the request, you can trigger those serverless containers from a variety of event sources and receive events such as Kafka message and file upload to the storage, timers for recurring jobs, like that. OpenShift Serverless is based on this open source project Knative, one of the fastest growing serverless projects in the market. This ensures that you don't suffer with lock-in concerns and can still get the innovation from a growing open source community. So the last feature of this session is a cloud-native CI/CD with OpenShift pipeline. Cloud-native CI/CD is based on Tekton pipelines. This can run serverless, and containers build images with Kubernetes tools, S2I, Builder, and etc. Pipeline is able to be portable to any Kubernetes distribution. This is available in the Operator Hub. Tekton pipelines VS Code extension enable create, trigger, and manage Tekton pipelines on OpenShift and Kubernetes from Visual Studio Code. And also, you can still use Jenkins container in the OpenShift cluster. Compared to OpenShift 3, Jenkins server runs on JDK 8 and 11. And there are two types of Jenkins agents, JDK 11 and Node.js 10 is providing. You can install through Open Operator Hub IO, and you can still use Jenkins for writing CI pipeline in the OpenShift. So this is my end of my presentation. Thank you for hearing and listen my session, and I will hand over to the chat.
Okay, thanks so much, Edwin. We'll pass over to Chuck right now.
Hello, everyone. My name is Chakra. In this, so far we have seen from my Red Hat and then as well as Microsoft colleagues, you have seen why you should be considering ARO in terms of business perspective, and as well as what's new in OpenShift 4.3 or ARO 4.3. I'll be mostly taking you through the journey of why you should consider ARO from the reasons of technical perspective, and as well as most of your steps in onboarding enterprise applications to ARO. We have seen this already from Ashwani and as well as Edwin on why Kubernetes done right is hard. I would like to highlight the biggest thing why you should consider ARO with respect to security. If you're just getting started with adoption of either Kubernetes or a distribution itself, maybe you're trying out a number of installers that are there in the market. I can say clearly about 50 to 60 different installers, popular installers you have that you want to try and then get the Kubernetes up and running. The problem with this is most of the installers that you have, these are not really checked for security vulnerabilities most of the times. The images that comes along with these installations are untrusted, and then they're not really looked after for vulnerabilities frequently. I wouldn't say it is zero, but it's not a common practice for these installers to look after vulnerabilities. See? And as well as when you are configuring your first Kubernetes cluster, maybe the security rules that you have that comes along with these installers are more designed towards adoption, not really for enterprise usage. And as well as making sure your container platform is ready with respect to OS hardening or platform hardening in terms of planning for your platform upgrades. All these are not really looked after. This is something that you have to invest on your own. Maybe you end up spending 3 months, 4 months just doing this, all these in a controlled fashion, as well as making sure it is right. So all these effort that you put in, you can avoid by leveraging on ARO itself, because ARO itself is hardened by Red Hat and as well as Microsoft for the operations part and Red Hat for the image security and OS security, so that you don't need to spend that 6 months or 4 months time in bringing the container platform to your enterprise. With that, let's look into some of the technical features of ARO itself, on why you should pick up ARO versus maybe have your own OpenShift installation that you would like to try on your infrastructure. These are some highlighted ones. We'll go a little bit deeper on each of them, but at the high level, what it would be is making sure you have the same kind of control that you have on an on-prem environment for handling the OpenShift operations. You also have it on the public cloud environment. That is what Microsoft is making sure, giving that features that you require to run the same environments on a public cloud, which gives you much more flexibility, and as well as plugging into the Microsoft ecosystem, the other applications that might be running already there. So let's take a look at each of them in a little bit deeper. Let's start with the starting thing that you look at here is creation of the platform, the Kubernetes or the OpenShift platform itself is as simple as doing AZ arrow create. This, if you have to do it on your own, making sure that it is repeatable, making sure whenever you don't want the capacity that you want, taking it down to minimal size, saving on your subscriptions, saving on your overall support cost. These all things cannot be done if you are going with standalone installation that you typically do on your own. Whereas with AZ, with the tight integration with the CLI itself, you can spin up a cluster, pay for what you use, and then destroy that cluster. This is especially useful if you are doing maybe a small POC, or maybe you want to make sure everything is good before you actually do a big upgrade. Like all these cases, there are several scenarios that you can use this CLI tight integration with Azure to be able to spin up clusters on demand and then save a subscription cost in terms of spinning up clusters. And making sure the cluster itself is highly available. Typically, if you're doing it on your own, maybe you have a primary cluster and then you have a DR cluster. Most of the time, the DR cluster is unused, and then you are spending subscription cost and as well as infrastructure cost on the DR, although you're not really using them on a day-to-day basis. But you still need to have, because that is a business contingency plan. Whereas with the ARO itself, you are looking at a highly available architecture where your master control plane is spread across 3 different locations or availability zones in terms of in terms of the control plane, and as well as the worker nodes as well. So you don't need to spend time in making sure the platform is highly available. Red Hat and with partnership with Microsoft will take care of that, and the design itself will support you in that case. This is typically hard to implement if you're doing it on your own, as in you need to make sure the latencies between the masters are correct. The latencies between your worker nodes and masters are correct. There are several nuances on how much latency is allowed, without which the control plane goes into a confused mode, right? So a lot of things you can avoid just by using ARO and not spend time in investigating how to make it perfect. And as well as some of the other concerns with respect to financial institutions are how do I make sure the default cluster that is provisioned on a public cloud is safe, and it's not really, I'm not leaving out entry points like maybe exposing the API server outside to internet, which is typical in case of if you see any distribution of Kubernetes. By default, the API server is exposed outside. This has been heard by Microsoft and Red Hat, and then it was made sure that you have a choice whether you want to expose it outside or keep everything internal, everything private, and also make sure your workloads are able to talk to other workloads in the same VNet. You can deploy OpenShift or peer with the other virtual networks that you already have. So you can fully leverage the express routes and as well as the peering, VNet peering, and making sure your OpenShift itself is running on a existing VNet instead of creating a brand new VNet, which typically happens when you go with a 3.11 based installation. Whereas in 4.3, you can go with an existing VNet as well. So these are some of the things, the small things, but pretty useful for customers like financial institutions, who are very much careful about how the cluster is exposed outside and what are the entry gates into the cluster. And the other thing, if you look at from the when there is a platform as when it is a managed service itself, most of the times the things that you can do on these managed services are less. That is typically the case before, as in you cannot run privileged containers, you cannot change the configuration, because these things will affect the overall operations. And then if there is no right collaboration between the customer and as well as the operations team who is managing them, you might end up in situations where you have performed some upgrade and then upgrade fails because there's someone who changed something manually. This won't be the case anymore to a large extent, because you get full control of you get full control on the cluster, so you can perform cluster admin level operations, but also not compromise on the upgrade process. How it is achieved is OpenShift 4.3 or ARO 4.3 is mostly configurable from the UI, so you don't need to go to the host to do any configuration, and most of the configurations are taken care by the operator framework that is built into OpenShift itself to ensure that whatever configurations that you make won't break the upgrade process. So this operator framework itself has given a lot of flexibility for operators to change everything from the UI, whether it is a node configuration, whether it is a master configuration, all of those things can be done by UI itself. You don't need to go into a node and then change the configuration. It's like a no-touch environment. Everything can be done from the UI. So this gives you a greater flexibility on what you can do on the platform, and as well as flexibility for operations to be able to perform upgrades or patches or maintenance activities whenever they want. And also, I've seen customers spending a lot of time, months' time in making sure the platform that you installed just now is compliant with all the security compliances that industry typically needs. You run your security scans and make sure the scan results, you look at them, you inspect them, make configuration changes, and then spend a lot of time in making sure the cluster is hardened. Whereas with ARO itself, you can avoid that all that time, spending that time, and just pick up the ARO, which is already certified with the various things that you have seen that you see on the slide here. So you can definitely save a lot of time during the adoption phase. This is like a no-brainer, especially for enterprises who are serious about security. I think this is just this is very easy for them to adopt instead of worrying about hardening the platform itself. And also there are several other integrations with Azure itself, as in maybe you have a Azure Active Directory on the cloud, or your own AD that you have on-prem. Most of the times, there will be things on-prem, there will be things on the cloud. It cannot be like only cloud. It cannot be like only on-prem nowadays, right? So in order for you to seamlessly integrate the authentication systems or other connectivity, these are already provided by ARO, so that you can leverage either on-prem AD or a cloud AD and connect it as a authentication source for your platform. So you have a single way of accessing OpenShift rather than have two different sources of truth for your authentication. And also in terms of the subscription cost, and as well as making sure you scale on demand, it's easy as running few commands to be able to scale your nodes rather than pre-plan for your peak requirement and then spend more than what is required. So you can scale whenever you need. So you can start small or the minimal and then scale on demand, rather than plan for the peak and then starting to realize, should I take them out or should I not take them out, because once I installed, maybe it is very static environment. Whereas in ARO, it is a dynamic environment. You can scale up and down whenever you need. So these are some key considerations that why you should pick ARO versus having your own installation when you're just getting started with the adoption of a container platform like ARO. Let's look into some of the application portions of the onboarding process. Typically, when I speak to customers, customers are, if they're just getting started with Kubernetes or OpenShift in general, they might see a lot of options out there. Kubernetes in general has so many choices, it's sometimes overwhelming, as in you don't know which one to pick, right? Unless you are in that stream for 5 or 6 years, or like maybe it's from the beginning of Kubernetes itself, you don't know what is the best tool for this one. So what I've seen is typically you try things, see which one is good, which one is not good. So you end up spending a lot of time in trying out things. Whereas in ARO itself, it's a curated list. So if you look at in terms of what tools should I pick for monitoring? So for monitoring, it's Prometheus. What tool should I use for my image supply chain? It is your S2I, right? So you have a very opinionated way, of doing things. You can cross that opinionated way of doing things, but if you're a person, or if you're an organization who just wants someone to tell you, okay, this is how I should do image build, this is how I should do image tagging, or this is how I should promote, right? Without worrying about all the other options that you have, you just want to get things done. Maybe this is the right option for you, which you can pick up right away and then start developing value rather than spend time in investigating which is the best method. So this is where I see the value of ARO, where you have a opinionated way of doing things, whether it is image supply chain, whether it is scanning, whether it is promoting to production. All these things are some things that you learn over a period, typically in a Kubernetes adoption phase, whereas in ARO, you have a very opinionated way like that. And then you may be at different stage, right? Maybe you have a POC and then you want to move to next phase. Maybe you are just getting started with containers, or maybe you are in a phase where you already know you're already working on some of the on-prem Kubernetes distribution, and then you want to accelerate that adoption. So depending on the type of phase that you are, ARO provides different starting points for you. So when I say it is opinionated, you have a option to go with the opinionated way, but I see I've been in the OpenShift industry and as well as Kubernetes industry for a very long time. The design itself supports you for flexibility, but there is always a choice for you to go in a very opinionated way. So what happens in typically, let's say you are in a phase where you are on Kubernetes already on-prem, and then you want to move to ARO. The things that you might want to look at when you are migrating to, or when you are moving to ARO for onboarding is the pod security policies or the security contexts are slightly rigid on OpenShift compared to a Kubernetes distribution, because, like I said, Kubernetes is designed for adoption, not really ready out of the box for production usage. Then you might need to work on some ensuring some policies are in place. Sorry. You might need to work on some policies that you need to put in place for the workload to run on OpenShift. And also, you also might need to do some refactoring of the Docker images, because when you're running on Kubernetes, the security rules for running containers with non-root are slightly flexible, whereas when you move to ARO, these are not the same. So you might need to do some small refactoring of the images. So like I said, it's not like cut and paste. There is something you need to do, which is reality. Of course, there are some workloads which can just cut and paste, but there are some workloads you still need to do some amount of refactoring, which is good for you in terms of security. That is why you need to do. It's not because you want to use ARO. It is good for your application. That is why you need to do. You can relax security and then just get started right away. But my suggestion would be do it in the right way. Maybe in another phase, you are in a VM and then you want to move to ARO. You are looking at a very basic phase where you want to see, how do I start with the image build process? What are the trusted sources of for my images, right? How do I make sure these applications are running as non-root containers? For all these, there is a recommended way from Red Hat, from Microsoft, as in to choose what base images to choose. How do you ensure when there is a base image update, your application image also gets updated, which is a big deal in most of the enterprises, because as security is a very core prominent feature in the whole image supply chain, how do you make sure your application images won't break when there is a change in the base image? How do you ensure, how do you notify when there is an image change in the base and then you want to apply it in the application image? These are some small things that you might need to consider, but these are required things in case of enterprises that you cannot avoid. So doing this requires, like I said, a lot of time that you spend in basically figuring out what is the best way. But whereas in ARO, it is already a recommended way to do that. There are things you might need to look at when onboarding applications is maybe your services are using some system D services. Maybe they are using some kind of host level features. Maybe some special drivers that those are there. When you're moving to a ARO kind of environment, you need to also look into those kind of things. Some of the host level features, how you can move them to your ARO platform itself. So these are some things I observed when you are moving to ARO. You need to keep in mind. Particularly, I would like to stress on the image supply chain, as in the phases where during part of my consulting, the phases where you need to for the image build process itself is how do you ensure the notification of base image changes to the upstream images is to also look at some of the things like how do I use a major version, how do I use a minor version, right? Because the base image itself might have some breaking changes. And then how do I ensure what are the methods that I can follow to make sure I'm not breaking my application image. So these are some of the critical things that you need to keep in mind in order to ensure your image supply chain is solid. It can be a security patch as well, where the base image got a very big security patch. And then how do you make sure that base image may be used by 100 different applications? These 100 different applications, how do you propagate that update, right? And then without having to spend another 3 months into the patching process, how do you quickly ensure that your latest security patches are there in all the images? So these are some of the nuances that we need to keep in mind, which are very well practiced in the ARO. The application packaging itself, so I have seen this with many customers, like, okay, when I start with OpenShift or the distribution of Kubernetes like ARO, am I tying in too tightly with the platform, right? Like, am I using only OpenShift features so that I don't have an exit when I make a call? Like, I don't want to use OpenShift and then I want to go with something else. My recommendation is, if you have something that platform provides, use it. As I see, based on the experience, the exit strategy is not a big effort, because most of the packaging systems that you see can be converted from one form to another very easily. I would rather leverage the features and then fasten the value, rather than spend time in deciding whether I should use Helm charts or whether I should use OpenShift templates. So this is some typical questions that will come up whenever you start onboarding your applications. There is a very valid reason on why you don't want to tie into one particular thing, but also, like I said, the exit strategy is not that hard. And then use as much as the platform features so that you can fasten the value to the market. And the promotion process itself is another big thing, where you will end up in choosing the CI/CD tool itself. Like, how do I promote my application? Should I use a Jenkins, which is our external Jenkins, or should I leverage something which is part of the OpenShift? Again, my recommendation, either you use Azure DevOps or some kind of inbuilt CI/CD for OpenShift, rather than spend time on something, some other external tool which is not really built for container native technologies. It might be built for a traditional VM-based applications, but there is a larger community that is building up in terms of cloud native CI/CD tools like Azure DevOps, and as well as the Tekton built into OpenShift. I would spend time on those rather than trying to figure out how to make Jenkins work with OpenShift, right? This is my opinion when onboarding applications to ARO. And then also the monitoring and logging and the storage, right? These are something that need to be, in my opinion, outside the cluster, so that you are able to monitor your cluster and then collect all the logs. So even if your cluster goes down, and then you still have your logs out there, and then also you still have your persistent storage outside the cluster. So keep keep the cluster as much as stateless as possible, so that even if the upgrade fails or even if the complete cluster goes down momentarily, you still can recover because your state is outside. So as you know, the stateless applications are easy to recover, right? So keep your Kubernetes cluster as much stateless as possible. These are some of the things I would consider when you are onboarding applications onto ARO itself. But there are several other small things that you might need to look into when you're migrating to ARO. If you need any assistance in onboarding applications onto OpenShift, Azure Red Hat OpenShift 4.3, you can definitely reach out to us. There is a free half-day assessment that we can help you with for moving fast in your adoption phase. So I hope this was useful. I'm done at this point. I would like to transfer control back to Joan. Joan, take it over.
Thanks very much, Chuck, for your presentation. There are some resources available from Microsoft and Red Hat in terms of learning more, as well as a hands-on workshop and documentation. At the same time, our contacts are actually available as well for all the presenters today and supporting enablement teams. So if you have any queries or questions on implementing Azure Red Hat OpenShift 4, please do reach out to us. Thank you and have a good day. Thanks, everyone.